All right, guys. Today, I think we have two more sections left out of this section. I mean, out of this group of sections that will be on this first test. So today we're looking at our slope intercept. No, point slope form. This is out of 5, 6. All right. This one. All right. So your point slope form is y minus y1 equal to m times x minus x1, where m is your slope and x1, y1 will be the coordinates of any point on the line. So if you have at least one point and the slope of the line, you can figure out what the equation of that line would be by plugging it into this format. Also take note, equations that we dealt with up to this point had an x and y involved. So it could take on the form of, let's say, y equal to 2x plus 1. So this y and this x are supposed to be a part of your equation. It's the y1, once again, just reemphasizing the numbers that we're going to be substituting for. The y1, the m, and the x1 are the values that we're going to actually substitute numbers in for. X and y will still be a part of the equation when we're finished. Like I said, just like this equation over here. All right. So let's look at an example. All right, so write the equation of the line with the slope 2 and passes through the point negative 4, 6. All right, so they want us to write the equation of the line that has the slope of 2 and passes through the point negative 4, 6. So that means m is going to be 2, and the coordinates negative 4, 6 will provide us with x1 and y1. So rewriting the formula, y minus y1 equal to x, oh, not x, m times x minus x1. So that's y minus 6, negative 4 times x minus, oh, that negative 4 is not supposed to be here. I'm messing up all over the place. M is 2, and that's negative 4 inside the parentheses for x1. All right, questions on the substitution. 6 is y1, 2 is m, negative 4 is x1. So right here we have a negative to a negative. So don't forget that's a positive. And we need to distribute this 2 to each term. Now we can finish it off by adding 6 to both sides. Y is equal to 2x plus 14. Questions.
So that's how we have our points.
Well, that's how you can generate more points. Yes, you can throw something in for x and then figure out what y would be with that corresponding x value.
We put a one underneath the 2.
Oh, if you want to, yeah, you want to use the slope. Yep, you want to use slopes to graph. You can put 1 under 2. You would go up 2, right 1, because both of them are positive.
That'd be on the y-axis, right?
What you mean by that?
We would go up 2 on the y-axis, then 14 over.
No. If you were to use this, use the slope method for this one to graph. Your slope is 2, which, like you said, is 2 over 1. Your y-intercept is 14.
Okay.
And so up to right 1 is the information that your slope gives. Your y-intercept is 0, 14. And so you graph the y-intercept first. So that is on the y-axis, 0, 14. And then from your y-intercept, you would go up 2 and then right 1. And that will give you another point.
Thank you, Professor.
Not a problem, sir. Not a problem. So right equation line with the slope, -2, 3, and point.
I didn't discover the 1 until I was looking at one of the graphs that's in the homework.
Yeah.
And I just kept looking at it. I was like, it's 1 space over. Then the light bulb clicked on.
Yeah, man. But that's what that's what the process is for, man. Because once that bulb click, then no one can take it away from you. You know what I mean?
True.
And that's what it's all about, for it to register and that light bulb come on for you on your own.
And during the homework, I realized the Y is on top and the X is on bottom.
Yes, sir. That's why you rise. It's you go up or down for the top number, and then you go left or right for that bottom number, because when you look at your axes, your Y is your horizontal, and then your X is your vertical. I mean, I said it the opposite way. Your Y is your vertical, and your X is your horizontal. So that's why you rise.
Overrun.
Right.
It took me a while to get it, but I got it.
Professor Tucker. I have a question in regards. Is there a way to like memorize the people when you're recording? Because I actually go back and watch the videos. And sometimes it cover up the problems.
You said memorize the people?
Minimize, like when you're recording, so they don't show up?
No, unfortunately it's not. And so you're saying that it covers up the problem?
It covers up part of the problem. Some of the problem will be under the people. Like I right now I can look at and memorize mine, but like when I go back and watch the video.
I'll have to take a look at that, because I didn't know, because right now when I see it, I see I have you guys over to the left and I can write on the screen with no problem. So currently you see the whole screen, right? As far as what you guys see. Okay, so what you're saying is when you're looking at it on the videos that I've recorded, it's not like that.
You can see everything, but you can see the people too. So some of your writing is under the people. So it'll cut off some of them.
Yeah, unfortunately, wait, hold on, let me see. Okay, maybe this will help. Okay, I'll try this and see if that'll help moving forward. I just minimized it a little bit. I do want to be able to see when someone talks, so I didn't do it all the way. So let me know if that helps when you look at this video. And so this is the video you were talking about and everything like that. So you can see the change that I made and see if that makes a difference and let me know.
Yes,
according to what, what you were feeling like you had a problem with. So yeah.
Yes,
and then I'll try to, adjust accordingly. Thanks for letting me know about that.
You're welcome.
All right, so this next one is very similar to the one we just did. I just changed some numbers. Write the equation of the line with the slope, -2/3, and that runs through the point 50. So m is -2/3, x1, y1 is 50. And I will rewrite the formula. Y1 is 0. -2/3 is m. And then 5 is x1. All right. So y minus 0 is just y. -2/3, distribute into your parentheses. So it's -2/3 x. -2/3 times -5. So just to make sure we're okay with the process. So -2/3 times -5 is the same thing as -5/1. And all you would do is multiply across. -2 times -5 is a +10. 3 times 1 is 3. So that'd be a +10/3. Questions on that before we look at another scenario?
I got a question. Why do you write x and y to the left underneath the -2/3? Why do you put that there?
Well, that's the point that they gave us, which was 50. And yeah, they gave us the point right here, 50. So that's my x1 and y1.
Oh, okay. You trying to find the other point, which is blank over there.
Well, no, what we're trying to find is this equation right here. What equation fits that description? It has a slope of -2/3 and goes through the point of 50.
We still looking for the other x and y.
Oh no, you're not looking for x and y in this case. You're giving a slope, and you're given a point that the line runs through. You're given the slope of your line and the point that the line runs through. Notice it says write in the equation. All you want to do is figure out what equation fits this description.
Okay.
So, and that's what we did in the last one as well. What equation fits the description of having a slope of 2 and then goes through or passes through the point -4, 6? So in this section, we're figuring out what equation fits the description that they're giving us.
Okay.
Yeah. So we don't need another x, y. We just want to know what equation fits the description. All right, so write the equation of the line that passes through the points 3, 4, and 5, -4. So notice this one is different in comparison to the last two that we've done. And the main difference is that we do not have a slope. And since we do not have a slope, we need to find one, and we can do that with the given information. I'll call the first point that I come across x1, y1. Second point that I come across x2, y2. All right, so we have x1, y1, x2, y2. We can use the slope formula. That's y2 minus y1 over x2 minus x1. Y2 is 5. Nope, no, it's not. Y2 is -4. Y1 is 4. X2 is 5. X1 is 3. -8 over 2. My slope is -4. All right, so for the next step, now that we have a slope, we can use either point for the point slope formula. It doesn't matter because the line goes through both points. And either point you use, doesn't matter which one you use, you'll still get the same line if you do it correctly. So going back to the formula, y minus y1 equal to m times x minus x1. I would just go ahead and use x1, y1 since we've already labeled it x1, y1. But once again, it does not matter. You'll still get the same line. So y1 is 4. M is -4. X1 is 3. All right. Distribute -4.
Professor.
Yep.
I want to make sure I got this.
Mm-hmm.
Basically, the concept that you're teaching now is trying to figure out what formula to use to get something that's missing.
No. It depends on, well, basically the first thing you want to recognize is that we're trying to write the equation. We want to figure out what is the equation, but what equation fits the description that the problem is asking of us or giving to us. So we want to know what equation passes through the points 3, 4, 5, -4.
So the three types of equation that we use, we got to figure out which one to use.
Well, no, well, according to the information that's given to you, that will dictate what you do next. That goes back to solving, just like when we talked about solving. When you're solving, what dictates what you're going to do next is according to what has been given to you.
Okay.
And so in the previous one, we were given a slope and a point. So we use the point slope formula. That's the formula that this one right here that I initially gave you. That's why it's called the point slope formula, because if you have a point and a slope, you can use that formula.
Okay.
Now, when I come to the current example, I don't have a point and a slope. I have 2 points.
You got to find the slope.
Right. I can't use the point slope formula with 2 points. I need a point and a slope for that formula. So like you said, I need to find the slope. I can find the slope when I have 2 points. You see what I mean? So basically your first move is dictated, will be dictated according to the information that is given to you initially. So since they gave you 2 points with no slope, you have to use the 2 points to find the slope. Now, once you find the slope, you can use the point slope formula to go ahead and use point slope formula to go ahead and find your equation. Remember, your point slope formula is this one. But once again, you couldn't use this formula until you actually calculated the slope.
I think I grasped the concept.
Okay. All right.
Then once we get the slope, we switch to another formula.
Right. Mm-hmm. Let me see. Looking for, we're trying to see if they're going to ask you this type of question before I do anything else. They should. Yeah, there we go.
Now with this one, I'm just reciting to make sure I got it. We got the slope now. We can pick either point.
Yes.
Got it.
Mm-hmm. Mm-hmm.
Okay. To plug into the point slope formula.
Right.
Okay.
All right. So here we want to write the equation of the line that passes through 1, -1, and is parallel to y equal to 2x plus 3. So once again, they don't give us the slope outright or up front. We have to figure out what is our slope. This time we don't have 2 points, but we do have a key relationship that the line that we want to create, or the equation that we want to create, is parallel to the line y equal to 2x plus 3. All right.
We know it's parallel. The slope is going to be, if it was parallel, the slope is the same.
Yes, sir. Mm-hmm. And that is correct. So when you're talking about parallel, that means they're going to have the same slope. Mm-hmm.
I just got to remember all this stuff for the test. It's perpendicular when they have different slopes.
Right. They're all negative reciprocals. So the slope of this line is 2, because remember, whatever's sitting in front of x is your slope whenever it's in that y equal to mx plus b form. That's your slope-intercept form. Whenever your equation is solved for y, whatever's sitting in front of x, or whatever's attached to your x, is your slope. So this means the slope of our line is going to be 2 as well. So the slope of a parallel line is 2. And so now that we have a slope and we have our points, we can go ahead and plug in accordingly. Y1 is -1, 2 is m, x1 is +1. Distribute 2. Don't forget, negative to a negative is positive. Subtract 1. Y is equal to 2x minus 1. All right. Questions before we do another one? Do at least one more of these. All right, so here we want to write the equation of the line that passes through -4, 2 and is perpendicular to 2y equal to x plus 7. All right. So this time our line is perpendicular to this line. In its current state, I do not have a slope established. Remember, it has to be solved for y. So that means I need to solve it for y.
Divide everything by 2.
Yep. And don't forget that this 2 goes into each term in the numerator. So it's 1/2 x plus 7 over 2. This means that my slope is 1/2. Slope that's perpendicular. Remember, they're negative reciprocals, so you use the opposite sign and you flip the fraction. All right, so it's a slope that's perpendicular.
Okay, I have a question. So when you flip it, it turns into a negative?
No, not necessarily when you flip it. When you're talking about a slope that, because if you just flip it, let me do it like this. If you just flip it, then that's just 2/1. That's called a reciprocal. But if you want a line that is perpendicular to another line, then you flip it and make the sign negative, or use the opposite sign. So in other words, if my original slope was -10/7, then a slope that is perpendicular would be +7/10. So it is such a thing as just flipping your fraction. So I don't want to I want you to think that every time, or anybody that's listening, to think that every time you flip the fraction, you automatically change the sign. So that's not a thing. It depends on what you're doing. So in this case, for what we're doing here, trying to find perpendicular lines, you are supposed to flip the fraction and change the sign. All right. So you flip the fraction and change the sign for perpendicular, to find the slope of a perpendicular line.
Okay, I understand. I just have my nephew and he's trying to show out today with the
note. Look, trust me, every time I go on mute, it's me telling my daughter to be quiet. So just understand I'm with you. Yes, sir.
I got a question.
Uh-huh.
Now, I want to recite this, and I want to apologize there, but I want to recite this to make sure I got it. Now we got the equation in slope form, point slope form. I get it. Let's see, slope, then point slope. We're going to take it and look for a second. We're going to use the second equation now.
Right. So yeah, well, okay. So this equation, right? I just want to make sure we're talking about the same things. So this equation right here is in slope intercept.
Form. Slope intercept form.
Yep. Slope intercept form.
You got slope, then you got slope intercept, then point slope.
There you go.
All right. That's in slope intercept form.
Say the last part again.
That is in slope. Our answer is in slope intercept form.
Right. Well, this equation right here, we just turned it into slope intercept form. Right.
But if we still got to work it because we still got the other point.
Right. Because now this equation that we have right here is not our answer. It's just this equation in another form.
I'm trying to get it straight in my head. So we got, got it in point intercept form. We got to that part of the equation. Now we're about to get to the second part of the equation where we have to use point slope.
Yes. Right. And so now the point slope formula is going to actually help us to find the equation that we're looking for.
Okay.
So we converted this, they gave us an equation right here. We converted it to slope intercept form so we could get the slope. And we needed to get that slope. Now we're going to use the slope that we got and the point that they gave us.
To use point.
Right. Mm-hmm.
Sorry for being a little slow, but I just.
Oh, no, I mean, you're fine. We probably asking questions that
you got to look at these equations as
ask.
Sections. We got to break it up into sections when we're doing these problems.
Yeah, you should be compartmentalizing it, whether you say it or write it somewhere in your mind. You should be compartmentalizing what you should do and when you should do it. Yeah, I agree with that. All right. So we got our slope as -2, x1, y1 was -4. Yep, -4, 2. And we plug them in. So y1 is 2, m is -2, and x1 is -4. Make sure you don't lose a negative. I try to warn you guys about that as you plug in your values. Make sure you don't lose negatives. All right. Negative to a negative turns positive. So we have y minus 2 equal to negative 2x. And like I said, this is a positive. So negative 2 times 4 is negative 8. All right, and now we can add 2 to both sides. They cancel. Y is equal to negative 2x minus 6.
So basically, memorize 3 formulas and know when to apply them.
That's it. Questions, questions, questions. All right, before I change the notes. All right, so the next section talks about functions. I think this was 511. Let me go back. Yeah, it's called 511, section 511. I think, let me see if I can find it. Instead of rewriting this, let's start here. So we're looking at our functions. First thing we're going to start off with is the definition of a relation. A relation is any set of ordered pairs so 1, 2, 3, 4, 5, 6 is an example of a relation. The domain is a set of all of the first components of the ordered pairs. All right, so that's 1, 3, and 5. The range is a set of all of your second components of the ordered pairs. That'll be 2, 4, and 6.
Can you go back down?
Yeah, I say, can you go back down? Sorry, y'all, I'm writing slow.
I'm writing slow too.
I'll just mess with y'all. All right, so where y'all want me to go?
I'm domain the set of all first components of the order pairs.
Yes. Just let me know when you're ready, when you guys ready to move up.
I'm on range now.
Okay, yeah, you can move up. Thanks.
Not a problem at all, not a problem.
You can go ahead. I'm at 4 and 6 example.
All right. So your domain and range, this is your domain and range in comparison. Your domain will be your first components, range, second components. We already talked about that relationship. Your X variables for your domain, Y variables for your range. Domain is your input, your range is your output. In other words, domain are the values you plug in, the range are the values you get out. Domain will be your independent variable. Your range will be your dependent variable. So your range depends on the domain, if there was an explanation involved. Also, I didn't mention here, I think I mentioned it somewhere else. Domain will be your horizontal axis, range, your vertical. All right. Questions on that relationship before we move forward? All right, definition of a function. A function is a relation in which the elements from the domain corresponds to exactly one element in the range. All right, okay. All right, so determine whether each relation is a function. So, all right, so here we have 1, 6, 2, 6, 3, 8, 4, 9, and we want to know, does this relation, remember a relation is just a set of ordered pairs. Does this relation represent a function according to the definition that was just given? So what we can do is create this mapping of your domain and range. In our domain, we have 1, 2, 3, 4. In our range, we have 6, 8, 9. And so we have to ask ourselves, does each value in the domain go to one value in the range? exactly one value in the range. So, and look at them individually. Don't look at it as a whole, because looking at it as a whole will kind of convolute the process or your thinking process towards whether this is a function or not. So it says, does each value in the domain go to exactly one value in the range? So does 1 go to exactly one value? The answer is yes. Does 2 go to exactly one value? The answer is yes. Now, don't confuse the fact that 1 and 2 go to the same value. That has nothing to do with the definition. The definition says, does each value in the domain go to exactly one value in the range? Once again, look at them individually. Does the number 1 go to one value? Yes, it goes to 6. Does the number 2 go to one value? Yes, it goes to 6. 3 goes to one value. And then the number 4 goes to one value. So that means, yes, it is a function. So each value in the domain goes to exactly one value in the range. Questions before we go to the next one? And when we see the next one, they'll probably help you see it better. This is just re-emphasizing the fact that your X component is your first one. Y component is your second one. So all this was right here. Establishing here what it means to be input versus output. Your X is what we plug into the equation. The Y is what we get out. So 5, plug 5 into my equation, got out 11. So the same process. See, this class was, they didn't have the sections that you guys had previous to this one. They just started off in functions. So I had to go revisit some things for them. So those things didn't have anything to do with the problem itself. All right, so let's look at this one. We have 6, 1, 6, 2, 8, 3, 9, 4. Basically, all they did was invert the ordered pairs. Remember, it was 1, 6, 2, 6, 3, 8, 4, 9. So flip the fraction, flip the ordered pairs. We have 6, 1, 6, 2, 8, 3, 9, 4. And we're asking ourselves, is this a function? So we create the mapping once again. Domain 6, 8, 9 this time, range 1, 2, 3, 4. And we look at our values individually and say, does each value go to exactly one value in the range? And we see that 6 goes to 2 values. So that stops it right there. You don't have to keep analyzing. No, it is not a function. Because 6 goes to 1 and it goes to 2. Questions on the difference between a function and not having a function?
I probably have questions on Thursday.
Not a problem, sir. Sounds like a plan. Thursday will be open for that because we will be done with that first block of assignments. So before I do anything else, I want to leave that class as a review day for you guys to ask whatever you want to ask. And I was going to mention that before we closed out. So make sure you guys bring your questions next class, because I do want to make sure I entertain those before we do anything else. So just general statements from, the observations of those ordered pairs and what a function is versus what isn't a function. There can be a repeated value in the range, but no value can repeat in the domain. So we saw that we had 2 values. Remember, we had the 6. Let me go back. I'll come back down. Let me go here. Notice we have the 6 that is repeated in the range, and that was okay. That was still a function. But we didn't, or we couldn't have the 6 repeated in the domain. That's not a function. So that's what I mean by that. There can be a repeated value in the range, but no value can repeat in the domain. Or and the range can go to more than one value, but the domain can only go to one value. So just general statements from the observation of the ordered pairs that we had.
So don't write 6 twice in the domain column.
Right. You cannot have a repeated value in your domain column and it still be a function.
But the range, you can have a repeated value.
You got it.
Oh, Jesus. Yeah, I got to keep it.
Okay, one more thing out of this section, then we'll be done with it. Because I don't think it went to, yeah, it didn't go into function notation. All right, any questions before we do this last thing? Anybody still copying? All right. Just writing a note to myself. This is for me, not for you guys. All right, so let's go with function notation. All right, so this is for you guys, function notation. All right, so function notation is that y is equal to f of x, and you could use other function labels like g of x, or other letters, I should say, g of x, h of x, h of r. It just depends on what's going on with your function, what, especially in physics, what's going on, label of y's. But generally speaking, y equal to f of x. What that means is that as you guys progress forward, now they expect you to know that f of x is equal to y, and y is equal to f of x interchangeably. They could be in the same problem, explaining something, and switch from y to f of x to y, and expect you to know that they are the same thing. Okay, this is just considered function notation. So when you see that f of x or g of x or h of x or h of r, s of t, when you see that letter with parentheses and then the other variable, the variable that you actually plug in with, that is considered function notation. So what that does is that it gives you, or gives mathematicians or those who are dealing with the math, an option of giving you instructions without giving you any type of words. And so what I mean by that, and then as you get into math, you'll see that that is the flow, using more symbols and writing less and less words. So let's say they told you to find f of -3, or even if they didn't say find, if they didn't say find and all you saw was f of -3, if you want to know what f of -3 is, you have your f of x function. So you will plug in -3 into the equation. I need more room, so I'm going to bring this down. So f of -3, notice you plug in -3 where x is into the function notation symbol. So that means you plug in -3 where x is in the equation. Now f of x has to be established first. So they can't say find f of -3, but they have not given you what the function is, f of x. So f of x has to be given to you. And then you can plug in -3 into that function. And That is negative 5. So f of negative 3 is negative 5. Also, what that means is that the ordered pair is negative 3, negative 5. Negative 3 is what you plugged in. Negative 5 is what you got out. So that means negative 3 was x. Negative 5 was your y. Or negative 3 is your horizontal move. Negative 5 is your vertical move. Negative 3 would be a part of your domain. Negative 5 would be a part of your range. Negative 3 was your input. Negative 5 was your output. So all those things, coincide. Questions before I write another one up? All right, so if f of x is equal to 7x minus 3, g of x is equal to 9x squared minus 8x squared. I meant that should be 8x, not 8x squared. So 9x squared minus 8x plus 11. And HR, or h of r, is r cubed minus 5r squared minus 5. Find f of 1, g of 0, h of 5. And I don't think I mentioned that the way you say this is f of x. So that's g of x, that's h of r. So this would be h of 5. All right. So what we do not do, and I'm just mentioning this because I've seen it in the past, but once I began to put out the warning, people stopped doing it. You don't take 1, 0, and 5 and plug it into all the equations and give me 9 answers. So f of 1 goes to the f of x function, g of 0 goes to the g of x, h of 5 goes to h of r. So it's one value that you plug in to the corresponding function. So just making sure we're clear on that. So if I want to find f of 1, then I'm going to f of x function. And plugging in, 7 times 1 is 7, minus 3, and that's 4. Plugging in 0 into my g of x function. 0 squared is 0, 9 times 0 is 0, 8 times 0 is 0, plus 11, so our result is 11. All right, last one. h of 5. So that is 5 cubed minus 5 times, oh, didn't put a 5 in there. 5 squared minus 5. All right. 5 cubed is 125 minus 5 times 25. 5 times 25. 125. 125 minus 125 cancels, leaving us with just negative 5.
And all these answers would be our x variable.
You mean your y? It will be your y variable. It will represent your y. Yeah, you plug in your x, and then what you get out is your y.
Okay, y's.
Mm-hmm. All right. So try the stuff out. See if you have any questions. See if you get stuck. Next class is your opportunity for questions. I will not do anything new unless you guys come with nothing. I'm going to always assume the best out of you guys. So if you have no questions, that means you guys are good. And that's how I process it. So I need you guys to bring your questions in on next class so that we can address your questions accordingly and make sure you're ready for the test moving forward. Also on next class, we'll talk about your testing and communications with Mr. Davis and the testing center and all the good stuff like that. Any questions before we close out on today? Everybody good? Everybody straight? All right. So if you all are good, I am good. I will see you on next class.
All right, Professor, you have a good one.
Are you do the same, sir?
All right, have a good day, everyone.
All right, y'all have a good one.
Professor Tucker, this one was a hard one.